Today we're working on a 2015 Toyota Camry with a complaint that the passenger power window isn't up. Now that I've got it in the shop, I'll verify the complaint, then I'll have a look around the vehicle for anything else that may be wrong. Well, I was able to verify the complaint. Now I'll go ahead and have a walk around the vehicle and see if I see anything else. Well, I had a look around the vehicle and I didn't find anything else obvious that needed repair. I did notice that the 3 other power windows do work, and I checked all the fuses, and under here on the instrument panel junction block, I found one blown fuse, and that is the door number 3 fuse. So I'm going to bring up the wiring diagram and we'll have a look at that circuit. Well, I'm having a look in the fuse list for that blown 20 amp dome door number 3 fuse I found, and I see that it only powers up one circuit. So it's 20 amp door number 3 and it only powers the power window circuit. At first glance that looks like a bit of a complicated circuit, so I think before I dive into electrical diagnosis, I'm going to go ahead and get my tech stream and probably check some codes on this one just to make sure. Well, my health check's done, and I do have some trouble codes stored for the airbag. It looks like we're missing the driver's knee airbag here, but I don't have anything related to body electrical stored. So I'm going to keep moving on with my diagnosis from here. All right, so I want to trace current flow for normal operation on this circuit. I'm going to go ahead and start by coloring the section that gets power from the fuse all the time in red. And then I'll go through that fuse, color in the next section. I'm going to stop at that JL1 connector. I'll keep going down, following this gray wire that comes through that fuse all the way back to that front power window regulator over there. Now, everywhere I see on that red wire, I'm going to have 12 volts. That has 12 volts system source voltage. But I've got a problem on this circuit. I've got a short to ground that's occurred somewhere on the circuit. And I'm actually going to place it, we'll just place it right over here. Okay, and I'll bring that to the top. We'll just say right at this point we've got a short to ground. Right? Now, what's happened, since we have a short and we don't have a load anywhere on this circuit, right, anywhere on this positive side of the circuit, it's caused us to blow our fuse. So I'm going to install this blown fuse, right? That's indicating we've got a blown fuse. And now, instead of having positive voltage, because our fuse is blown, we don't have a path for voltage to flow through, for current to flow, and we're also grounded, right? We're grounded right here. So now this complete portion of circuit is shorted to ground. Everything that used to have 12 volts is now 0 volts, right? So our multimeter, our voltmeter, is not going to be very helpful at this point because everything's just going to read 0. We won't be able to tell anything about where the short is. So one thing we can do is, because the fault with this circuit is we don't have a load, I could take that blown fuse out, move it over here, and I could install a load. And in this case, it's a bulb that I've adapted to place in a fuse holder. I'm going to place that bulb in the fuse holder, and let's get it a little closer. And as long as it has power, which it does all the time, and as long as it has ground, which it does when I have this short to ground in place, as long as those two things occur, this bulb is going to be on. Now again, my multimeter doesn't help me a lot on this because all of this is electrically the same voltage. But what I can do is disconnect different sections of this circuit. And if I disconnect the section that has my ground on it, I know that I've disconnected the circuit that links my load in my fuse holder and the ground, right? I want to give you an example of this. I'm going to disconnect this section over here. I'm going to delete it. That's going to indicate that it's disconnected. But you see that portion of circuit is after this ground. So it doesn't affect the little makeshift circuit we have where our load is in place of this fuse holder. This still looks like a normal working circuit, what we started off with in the basics, right? But if I disconnect this section, my bulb will now go dim because I do not have a ground. I no longer have a path for ground, right? So if I disconnect a section and my bulb goes dim, I know either that section or a section after it had the short to ground. This is how I use this technique to show me where in a vehicle a short is. So we're going to go on to the actual vehicle and do this same test. So as I suspected, it looks like we've got a short to ground causing this fuse to blow. So the first thing I'm going to do is figure out which side of this fuse has power and which side of it shorted to ground. I'll go ahead and put my multimeter on DC voltage. I'll put my meter clamp on a known good ground. And I'm going to go ahead and test probe the fuse holder terminals. And I've got voltage on the side closest to the driver's door. I've got no voltage on the other side. And the next thing I'm going to do is figure out which side is grounded. So I'll just put my meter to continuity. I'll go ahead and turn my buzzer on so you can hopefully hear it. And we'll double check and make sure that the passenger side of this fuse holder is grounded. All right, it looks like it's grounded and it's only got about 0.4 of a volt to ground. Now, we know we have a short present right now. We can't keep putting fuses in here. We've already probably blown a couple at this point and they're not cheap, right? So we want to do something else in this. We don't have a load in this circuit because that short to ground has bypassed our load. That's why our fuse is blowing. So we need to put something in here to slow down the current. We need another load inserted in the circuit. Since we've taken that fuse out, that'd be a great place to put another load, but we need some sort of device to adapt that. I just so happen to have something like that. And this is an adapter that just basically puts large terminals on a legless fuse, and on the other end I have a load that I've measured out. It's a little bit less than 1 amp, right? So this is going to be safe to insert in this circuit. We'll only have about 1 amp flowing through it, right? And it's going to ground through that shorted portion of the circuit. So if I put this in here and it lights up, that means our short is present. Right, now we have a really good visual indicator to help us diagnose this short. If this short goes away, this light is going to turn off, so I'll know when I've found the cause of our problem. We're back here at JI1 terminal 18, and we know this wire is B+ for our power window system, and it should have source voltage on it. So I'll go ahead, hook my ground up to this metal bracket on the dash, and I'll test for voltage at that terminal. And I'm showing about 0.2 volts, which sounds an awful lot like the ground side of a circuit. So I think we are grounded. Again, we have a short to ground. I'll go ahead and remove my meter. It's not going to do us much good other than that on a circuit like this, on an issue like this. I do know that if I unplug the ground for a load, that load should turn off. Now let's go ahead and do that. I'll unplug JI1. I'll have a look, and it looks like my bulb did go off. So now I know that the ground, the short to ground, causing this circuit to blow that fuse is now gone. Now I need to know which side of this connector that short is on. That's really important. Well, the way we tell, if you remember on that diagram, the side closest to the fuse had male terminals. And we have male terminals and female terminals, and it's not always the plastic that we're looking at. An easy way to remember this is that the metal matters. So I can see that this side has female terminals. That's the side I need to start checking for my physical short to ground to be on. Well, it didn't take very long. After a short inspection, I found that all of these black wires are tapped into our circuit 18, that gray wire at JI1. Of course, this is a training center vehicle, and we know the bugs are intentionally installed. But again, most of your faults are near a connector, near a kick panel, or something that moves like the door, where it could get pinched or broken. So we'll go ahead and flip that switch, reset this fault, and continue our testing to verify the repair of this vehicle.
Well, now that we've got that done on the vehicle, I want to wrap up what we've seen on our diagram and make sure that it's all clear. First, I've got a close-up of JI1 showing the male and female terminals. And when we disconnected JI1, remember that our replacement load went dim. All right, so that turned off. Now that indicated that our load, our short to ground, was no longer present. Right? Now, which portion of the circuit did we eliminate when we disconnected JI1? I want to put this X over here just to remind us where we're disconnected at. All right. Which portion did we disconnect? Well, it was all of this portion of this circuit, right? It's basically the remainder of that circuit. I'm going to go ahead and make that a different color. We'll color it really light green. So we know that portion of the circuit is no longer in effect. Our bulb went out. So we know that our short had to have been somewhere in that section of circuit, right? It could have been anywhere along here. Because this is one long piece of wire, I wouldn't be able to actually tell anything more than that by disconnecting it. Now, when we inspected that area, we did find the actual cause of that short, right? And that was very close to the connector itself, very close to connector JI1 itself, if you'll remember. So that's explained. That's the schematic explanation of what we found on our vehicle.
Well, I've got a new fuse ready to install, but they're kind of expensive. So before I do that, I want to go ahead and make sure that this short is no longer present. Again, this is part of verifying our repair. An easy indicator is that the bulb that I've placed in that fuse holder is no longer lit up. It no longer has a path to ground. But I'm going to do a little better than that. I'll pull that out, and I'm going to use that same test we did with our multimeter earlier. And I'm going to check resistance, continuity on the right side of this fuse holder. And last time we had a path to ground and it beeped at us. This time I'm touching that and we do not have a path to ground. So we've verified that that short's gone, and I should be able to go ahead and put my new fuse in there. And now we can check the operation of our passenger power window. Looks like we've got this one fixed. This time I'll probably have a look around the vehicle, just make sure I didn't cause any other issues before I go ahead and get this one ready to ship. So testing short to grounds is definitely something we want to have a strategy before we start testing and unplugging things. Fuses are expensive and it's really easy to get lost in the diagnosis of these types of problems. What we really want to focus on is knowing that the short to ground is providing a ground for the light that we have in that fuse holder, and when we take that ground away, we've proven where that short is. Now again, we definitely need to know what the male and female terminals are when we unplug something so we can tell which direction to go in for our diagnosis. Use these tips and I think you'll be able to diagnose short to grounds pretty soon.